at all this stuff, I know what my tension is in my string because I used 300 grams, right? Yeah, of mass. I used a constant mass. So we would have 3. Ooh, it's a big square root. Do you think, and I knew the length of my string, or the lengths that I was changing, do you think maybe I could find my mass per unit length from our experiment yesterday? Yes? Okay. Which I'm going to make y'all do in a minute. Get really excited. So, but what if I put a sound wave into some kind of pipe? What does that remind you of? A sound wave in a pipe. An organ, yeah, some kind of musical instrument. And the first kind of pipe I'm going to look at, it's open on both ends. Okay, so it's an open pipe. And these open ends of the pipes have to have antinodes. Like, we have to start and end with an antinode, okay? So the simplest wave I can make that would end both ends in an antinode looks something like this. And I'm drawing them like standing waves. Really, they're like a longitudinal wave that moves as a transverse wave, and that's really hard to draw, yeah? So I'm just going to draw it as a standing wave, but it's the same business. So let's see. If we use the same reference point that we did before for one wavelength, but this time I'm going to actually split it up into 4 parts because that's going to make it easier. So I have one part here, one part here, one here, and one here, okay? So how many parts of a wavelength do I have inside of this right here? 2. I have 2/4, right? So I kind of have this middle center business. So I have 1/2 lambda is equal to this length, or 2L. So then I get the frequency is equal to V over 2L. Okay. Okay, but let's look. So technically, this is also the first harmonic. So there's 2 different ways that you can look at this pipe and tell whether or not it's in the first harmonic. The first is, now that it's inside of a pipe, the number of nodes is the harmonic number. So we have 1 node, so it's in the first harmonic. You can also look at the number of complete loops that you have. So do you see how this part right here looks like half of a loop? And this part right here looks like half of a loop? If I combine those, what do 2 halves of a loop make? 1. So it's in the first harmonic because it has 1 loop. Okay? And the first harmonic is also, this is just a side note for when you get your problem set. The first harmonic is the fundamental frequency. Okay? So that's a way that they refer to this first harmonic. And that's in a pipe, outside of the pipe, all the time. First harmonic is fundamental frequency. So now I want to look at the second harmonic inside of this pipe. How many loops do I have here? How many complete loops? How many? Don't I have 2, right? I have 1 complete one here, and then I have a half and a half. So what's 1 plus 1/2 plus 1/2? It's 2, yeah? So, and then how many wavelengths do I have? If this is still 1 full wavelength, and 1, yeah, because this would be 1/2, and then we have another 1/2 over here. Okay? Are we good with this? Okay. So our wavelength is equal to L, which makes our frequency equation V over L. Alright, so I'm going to look at the third harmonic now and see if we can come up with another pattern. Alright, so how many wavelengths do I have here? If this whole complete guy right here is 1, do you think maybe this is a half? Because we decided up here that this was 1 wavelength. So now I have 1.5 wavelengths. Okay? That would make my wavelength 2/3 L, which would then make my frequency equation look something like this. So now if I want to compare my 3 harmonics just like I did last time, what do I have? I have F is equal to V over 2L, F is equal to V over L, and F is equal to 3V over 2L. Does that look familiar? What does it look like? It's the same as last time, so I can put some 2's in here if you want to see the whole picture, and a 1. So again, my equation for open-ended pipes, when both ends are open, is still F sub n is equal to NV over 2L. But what do you think my velocity is here? If we have sound waves moving through an open pipe, doesn't speed move at a certain sound? Whoa, that was backwards. Sound move at a certain speed? The speed of sound, yeah. And that is 343 meters per second. Alright, so now I want to look at a pipe though that's not open on both ends. And just a little spoiler alert, this one's not going to be the same as it was for the last 2. So now I have this open, closed pipe. So if the part of the pipe that's open has to have an antinode, what do you think the part that's closed needs to have? A node, yeah. So if I were to draw these pictures, the simplest wave I could draw that started with a node and ended with an antinode is going to look something like this. A little more open on the ends. So using, again, the same point of reference as the last one, how many wavelengths do I have here? If this is 1 part, 2 parts, 3, 4, how many parts of this is that? Maybe 1/4? Maybe it's just this top part right here? Yeah? So 1/4 of a wavelength? So then my wavelength is now 4L, which would make my frequency equation V over 4L. Alright, so what about this wave? How many wavelengths does this have? If we go up to the picture, and this is 1/4, 2/4, 3/4, and 4/4. So now we have 1/4, 2/4, 3/4. Yeah. So we have 3/4 of the wavelength is equal to L. Which would then make my frequency equation look something like this. Alright, so let's look at one more and then see if we can come up with one last relationship. How many wavelengths do I have now? If this, so we have 1/4, 2/4, 3/4, 4/4. So how many? 5/4. Yeah. Alright, so I'm going to take a look at my 3 that I've made so far and see if I can come up with this last relationship for the closed open pipes. So let's see, my first equation was V over 4L. And my second equation was 3V over 4L. My last was 5V over 4L. So do you see any relationships here? What about the bottom of this equation? They're all 4L. So any guesses about the top? Could put a 1 there. Yeah, it's only odd harmonics. So our equation is going to look like this. F sub n is equal to NV over 4L. But this only, an open closed pipe only makes odd harmonics. So before, when we had just a standing wave, we had two nodes on the end, so it was symmetrical. And then when we had one in an open pipe, we had antinodes on the end, so again it was symmetrical. But for a closed open pipe, didn't we have a node on one end and an antinode on the other? Yeah. So for a closed open pipe, there's only odd harmonics. Okay. How far?